Right, so I mean, forgive me for not putting this on the revision list, but it just didn't seem worth it. So my interquartile range is 37, so Q3 upper quartile, take away lower quartile Q1, which is 16, so that's 21. And remember how we work out the median, that's the middle value. The lower quartile is the median of the values below, the median of the values below the median, upper quartile median of the values above the median. And we are told in this set of data that outliers are anything smaller than 1.5 interquartile ranges below the lower quartile, or anything bigger than 1.5 interquartile ranges above the upper quartile. So 1.5 interquartile ranges, should be able to do that, shouldn't I? So that's 31.5. Is that right? 10.5? Yeah, 31.5. So the answer is no, there are no outliers in this set, because this is negative, and the lowest value is 4, and this is 68.5, and our maximum value is 49, so no outliers in this case. The definition of outliers varies, and you'd always be given it in a question. You can have outliers in a question where you've worked out standard deviation. That tends to be so many standard deviations away from the mean, because standard deviation is a measure of spread either side of the mean, so that would be how that would be done. Any questions about that? Good stuff, good stuff. Right, I promised you another little present. Yeah, this is quite exciting as the last one. So this is your own printed copy of the formula book. So you don't need to bring this to exams. This is for your use, and I hope that you're going to scribble and highlight and draw all over it, just to sort of identify the things that are in there. The first thing I need to say is there isn't much in there that's useful. It's full of all sorts of stuff. Here you are, George. This is yours. Full of all sorts of stuff, which is either not needed. Now we've got these fantastic calculators, like all the tables at the back, or it's stuff that applies to further maths, which unfortunately we're not able to offer. So actually the bit that applies to A-level maths is actually that. Okay, so it's from page 5 through to page 8. That is it. That is it. So it's a big, scary booklet full of all sorts of horrible stuff, but actually the stuff that we use is 5 through to 8. And even that is a repeat of a lot of the stuff from before AS Maths. The stuff that relates to what we've done this half term is on page 5. So you've got the sum of an arithmetic series in both forms. You've got the formula for the binomial series. You've got at the top there, you've got the one from last year, which I never showed you because I just think that's so confusing. It's much better to just learn a plus b to the power of 4. It's descending powers of a, ascending powers of b with a coefficient. But the 1 plus x to the n, that's the one we've been using this half term. We've got geometric series at the bottom there. We've got a formula under logs and exponentials, which we haven't used yet. That's how you change the base of a log. So if you've got something that's log to the base 2 and you want to know what it is in log to the base 10, we will be doing that. Over the page on 6, we get excited. It says trig identities, but they're not the ones that we've used so far. We're expected to remember those. We will come to these. But you have got the small angle approximations, and that's something that which will be on the mock. That's what we did when we did radians, so they are there. You've then got a load of differentiation and integration, which we come to, although actually we use hardly any of it, and again it looks so complicated, it's not. And then you've got the kinematics formula at the end. It does give you the formula for standard deviation, but it gives you the raw data one, so I think it's much better to learn it And yeah, a lot of the stuff there is just we will never use. And
So is this what you've been given these out?
so yes. And these tables at the back are either things that don't apply to us, they're from further maths, or they are probabilities from the binomial distribution, which we don't need to worry about because your calculator tells you. Just feel pity for the people who had to do this a few years ago because the calculators didn't do it. So stop for a minute. You were drinking a can of beer then. I thought that would be a first. I think. Yeah, I think it would be a first. Yeah. Right. So I feel like I ought. It's part of my duty to give you this, but how useful it is, this is there. Don't feel you have to bring it to every lesson, but it is useful, I think, being prepared for what you're going to be doing. Right, we are proving and solving. So we are midway through a question that we were on yesterday, and then we've got one more to do, and then we've got one more thing, and then we draw a nice line under the reciprocal identities. Except I did promise you that around mock time we would do some more practice of proving and solving in those funny sort of in-between lessons when you're in and out of the exam.
That's funny.
There aren't many mock exams, are there? So you've only got maths. Yeah. So Charlie, you've got 4 or 4 of it. Right. Yeah. I mean, I'm not suggesting it's not a big deal. Can I just say though, in terms of UCAS, these mocks are relevant. Okay, so everything in terms of your UCAS projected grade and all that sort of stuff, references, that's all fixed. Okay, so this mock series is about you getting valuable experience. That's all. All right. Sorry.
Because they'd be relevant.
Well, yeah, I guess yes, if you do really, really well. But I think, if obviously we drop below the magic 30% again, then alarm bells will go off. But I think we're set on a course now, so nothing's going to change that course. We just, I think, see them as valuable experience, and I'm not suggesting that makes them less stressful, but I'm not going to suddenly phone UCAS and say, by the way, I predicted them an A, it's no longer an A, it's now a C or something like that. That's not the case. Right. So we've done the proof. I think we've done the proof bit, haven't we? It was this rather odd thing because we ended up with a fraction divided by something, and we had to sort of stack the two things, the two denominators into one denominator. But we got there. So this is such a classic question because part B starts with the word hence. And that word hence means this next question is not plucked from the air. It has got in some way to be related to the first part of the question. It must in some way be related to all the work we've done so far. And so the first thing to do is to work out what's in common. And it's fairly obvious, isn't it? This thing is the same in both questions. Now, you often get hence questions where it's not immediately obvious what is the same. But this one's nice and obvious. So we're being asked to solve when does this equal 2, but we've just shown that that actually is the same as cosec. So what they are begging us to do in part B is say, well actually, working out when that equals 2 is the same as saying when does cosec x equal 2, which is a much easier equation. The answer to this is the same as the answer to this because I've just proved the two are the same thing. And if cosec x is 2, I know that, or sec, third letter of sec is cosec is s, so I know that sine x is 1 over 2, so I'm going to do shift sine. I'm going to do shift sine, making sure I'm in radians, and I remember that that's 180 degrees, so that's the sine curve for those regions. So for a half, I know I'm looking for 2 solutions. So see if you can just finish that one off for me. Are we all calculated up to this? So this, George, was on page 153, question 9. We started it last lesson. I'm just going to let the video run, so I'll assume you'll fast forward through the bits that you don't need. Shift setup. Hopefully you're used to it by now. Bit of a pain, but there we go. So Tegan, what does shift sign of a half give you?
1/6 pi.
Yeah, 1/6 pi, which I tend to write as pi of 6, but it's the same thing. So go on, Beth, what's the other solution here going to be?
Did pi take away 1/6 pi?
Which is 5/6 of pi. Well done. Yeah, brilliant. And no solutions in the negative area, so we're all okay there. Just those two solutions. Good stuff. So proving and solving in the same question. I really like these. Let's do another one. So we're going to jump to page 163 and question 19. Now, if this prove thing looks a bit familiar, well, there's a reason for that, but try and do it without looking back at yesterday's notes just to see. Difference of two squares. So that can be factorised as sec squared theta. Well, I'll leave you to do the rest. So start working on the left-hand side in your proof section. If you're completely stuck, obviously you looked at yesterday. Now notice how I started by writing out my identities. Now you may have done that at the start of the exam, or you may have done it as you needed them, but I absolutely promise you that I don't remember these, okay? I don't remember these. I have to derive them each time, and it didn't take me any time at all right? And you might say, well, you're a maths teacher, but it's 2 years since I last used these, because it's only comes around every couple of years. And your brains are a lot younger and alert than mine. So I'm hoping you'll get into that habit. And I know it's still new, but believe me, by the time summer comes, you'll be seeing it in your sleep when you close your eyes. So anyway, that was one we'd already done yesterday, or very similar. Was it that exact one? I think it was that exact one, wasn't it? Yeah. So now we've got to hence solve something, but this time I note that this doesn't look the same as this, does it? So it's not immediately obvious what we need to do like it was in the previous question, but it's a hence question. So it's got to be something to do with this. The worst thing is when you're marking something like this and someone tries to solve this from scratch without realising it's in some way related. So what are we going to do? What are we going to do to start off with part B? What do you reckon, Lily? What would you do? How can I make this look like that? It's all right. What do you reckon, Grace? What could?
Minus
Brilliant. Yeah. So that's our starting point. So this is what we're being asked to solve. And the fours mixed up. There we go. And so I'm going to start by making this look like this, as Grace absolutely correctly identified. Now, of course, okay. Now I've got that. So they must be wanting me, and it's not immediately obvious why in this case. It was obvious in the last one because it was so much simpler. But they must want me to replace this with this, because I've just shown they're the same thing. So I'll do it. I'll do what they want. They want me to replace that with sec squared theta plus tan squared theta. And we were solving equations. Did I open there, George? Sorry. We were solving equations like this yesterday. It's going to be a quadratic in tan. The only thing that spoils it at the moment is that pesky sec squared. But of course, we've got a way of replacing sec squared with something to do with tan. Go on, bring it home for me. We're back in degrees. Back in degrees. Once you get your quadratic, line it up, 0 on the right hand side, use your calculator to solve it. Those will be your tan theta solutions, so you're going to shift in those to get your theta solutions. with tan, everything's valid, isn't it? Tan, you can, you know, sine and cos can only be between 1 and -1. Tan can be any value. I mean, both of these are actually within range, but tan's nice and easy, isn't it? Because you've just got solutions every 180 degrees. So if you get a negative solution, add 180 to it. If you've got a positive, take away 180 from it. Should get a half and 1 as your tan solutions, and that gives you those 4 angles, 45 and minus 135 for 1, and then the 2 rounded ones for a half. So prove and then solve. Those are you know, classic trig questions. And notice that, you know, we are, as I said the other day, so far now from trig in primary. This is just algebra now, isn't it? You know, so just like we've been manipulating quadratics and cubics and all that sort of stuff, we're now using trig in our algebra. I'm obviously not going to set you one to do for next lesson, because next lesson is some time away, but if you wanted to try one that was similar but slightly different, and you can check it in the solution bank, page 157 question 9 is a good one, which is, it's not quite a prove and solve, but it's a hence question. So part A helps you with part B, and I would recommend you having a look at that. But there's one more thing I want to do before we leave the reciprocal functions and the reciprocal identities. And before that, I want to go back to something that we did last year. Do you remember doing questions like this at last year? It would say something like, angle A is obtuse, and sine of A equals 4/5. Find cos of A and tan.
What title?
Right. This is finding missing reciprocal functions. Now it is tempting to say, well, all I'll do then is I'll do shift sine of 4/5, work out the angles and find the obtuse one, and then I'll do cos of that angle and tan of that angle. But you may remember that actually that's, although with these calculators that will give you the exact answer, excuse me. Sorry. That we don't actually do that. We instead use our identities to get it sort of properly, old school. All right, so you know we pretend that we're not equipped with these fantastic calculators. We do it old school. So we use this identity here because this identity, which we've been using as part of our algebra, you can actually plug numbers into it. If sine A is 4/5, then sine squared A is just 4/5 squared, 16/25. And if I want to know what cos A is, well, I know that that plus cos will equal 1. So I can work out cos by doing 1 minus that squared. So see if you can work out the value of cos A. You'll get a plus or minus answer because you need to square root. fed up with doing 3 equals 1. So. So, using that identity, 1 minus 16 25ths is 9 25ths. So that's what cos squared, sorry, I'm using x instead of a, forgive me. So cos is the square root of that, which will be plus or minus 3/5. However, we are told in the question that a is obtuse. Obtuse, remember, means an angle between 90 and 180. If I look at the cos curve between 90 and 180, the cos is always negative. So, it's minus 3/5. And do you remember the cast diagram that we used to help us remember whether we're dealing with positive or negative sines, coses and tans? It means we don't have to always draw the graph. This diagram shows angles from 0 to 360 going around in a clockwise direction. And it reminds us that between 0 and 90, all of them, sine, cos and tan, are positive. So the diagram is showing us what's positive. Between 90 and 180, only sine is positive. Between 180 and 270, only tan is positive, sine and cos are negative. And between 270 and 360, only cos is positive, sine is negative, tan is negative. So that cast diagram helps us remember in questions like this whether we're dealing with positives or negatives. So Isabel, I've got the sine, which is 4/5. I've got the cos, which is minus 3/5. How am I going to work out the tan? What's the other identity that we had last year? We've got that one, which we've already used.
Oh, I wish I could tell you.
What's the one linking tan to sine and cos?
Oh, sine over cos.
Sine over cos, yeah. Which we've so far just used in algebra, but we can actually use it with numbers. So the tan of this angle is the sine of the angle, which we've just worked out is 4/5, divided by the cos of the angle, which we've just worked out is minus 3/5. So that's going to give us minus 4/3. So that was last year. We did. You may remember it. I don't know. It's a good thing to revise. So what we can now do is the Year 2 version, which uses the reciprocal identity. So we've just used the two identities from last year. That tan was sine over cos, and sine squared plus cos squared is 1. What we're now going to use is, well, we'll still use those as well, but we're going to also use the reciprocal identities. So, for example, here we're told that tan of an angle is minus 5/12, and we're asked what the sec of the angle is. Well, here, look, I've got an identity linking tan squared and sec squared. If tan is minus 5/12, tan squared is that squared, which will be plus 25 over 144. So go on, have a go. See if you can work out what sec is. And remember, sec is 1 over cos. And if cos is negative, sec will be negative as well. We're dealing with obtuse angles again. So that should help you when you come to square root decide if it's plus or minus. So tan squared is the tan of a squared. So in this case, we're going to just square that number and use it in this identity. Once you've got sec, see if you can work out how to work out sine. See if you can do the second bit as well. So I'm hoping you got minus 13 over 12 because sec squared is tan squared plus 1. Tan squared is plus 25 over 144. So add 144, 144ths to that, you get 169 over 144. Square root that is plus or minus 13 over 12, but because it is obtuse, only sine is positive for obtuse angles. And if cos is negative, 1 over cos, sec will also be negative. So Pat, now I've got sec, what can I write down straight away without thinking? Remind me what sec is. 1 over cos. So tell me what cos A must be then. If sec A is that, minus 12 over 13. Yeah. And to work out sine A, we just do the process we did a second ago, which uses that identity. That's the year 1 identity, isn't it? So, except we did it the other way around. So, if I say, okay, I know what cos squared is, sine squared A is 1 minus cos squared A. Well, I know what that squared is, I've only just square rooted it. If we flipped over, obviously, but. And this time I'm asked to find the sine. Well, I know the sine of an obtuse angle will be positive. So, see if we can finish that off. So yes, Grace.
I just did tan A cos A.
Sorry, you did.
Tan A cos A.
Oh, genius! Fantastic. Yes. Got the same answer. So So just finishing off mine, you've got sine squared is 1 minus cos squared, so you end up with 25 over 69. The square root of that is plus or minus 5 over 13, but I know that's going to be positive, and so Grace has done it probably even more elegantly, well done, by saying, right, I now know that tan and 1 over sec, I know cos, and so sine A is just cos A times tan A. Yeah, brilliant, absolutely brilliant, yeah, brilliant. So all we're doing here is using these identities with actual values rather than just as algebra. So let's just do a couple of questions on page 156. I haven't got an identity linking cot and sine, but I have got an identity linking cot and cosec, and I know that cosec is 1 over sine. Also, this is another way of telling me it's an obtuse angle, isn't it? It's between 90 and 180, that's obtuse. So use your cast diagram to predict whether your answer is going to be positive or negative. So when you so what's if ignore the minus, what's root 3 squared? 3. But a negative times a negative is always positive. So it's going to be plus 3. And of course your calculator would do that for you. So we could use Knuth's method for this one as well, couldn't we? Because if I know what cot is, I can work out what tan is. So, I wonder if anybody will end up with something named after you. Something named after them.
You have, haven't you?
I've got children. Okay,
You've got
children.
Cooper's paint, haven't you?
Cooper's Paints, of course, yes, Cooper's Paints. Poor old lady, bless her. She was never sure. I've just used it here with my year 10s. I absolutely love it all the time.
I believed you as well. It was very believable.
And was it your group I did the stick business with? I'm fairly sure I went to, we had my stick business, sending sticks.
That's a bit less believable to be fair, but like you sounded serious about the paint company.
About me having a paint mixing company, yeah. Yeah, for those I did teach, when I introduced ratio, I'd always say that I had a sideline mixing
Yeah, he's
paints
always
in my
like-
gallery.
Like I've invested in like a paint company, like serious stuff.
So, no. Positive sign. So between 90 and 180, sign is positive. So yeah, I mean, I have to say I've always done 1 minus sine squared to work out cos squared, but I like Grace's method. Three and four. If cot is minus, then tan will be minus as well. You could write it as 1 over minus root 3. It's the same thing. It doesn't matter where the minus goes. going to run us shortly through to Jacob and Stasha, who are just next door. I quite like this. I think it's like sort of identity training. It's, it's if you want to get good at something, you need to practice it. And this is really good because you've got to decide which to use. Yes. So hopefully with 4 you're going to see this is the identity you need to use, because you've got tan and you are asked to find sec. Sec is 1 over cos, so part B is trivial, and then
Yeah. I mean, I haven't done stuff like this. As a house.
I didn't read how to go about it, I saw it. But I didn't know about it. I just thought it'd be
Right, I'll show you the answers to that one, but if you haven't finished it, then I commend it to you. Here we were dealing with an angle between 90 and 270, so whilst tan was positive, everything else will be negative. Sine and cos, and if sine is negative, that means cosec will be negative, and if cos is negative, sec will be negative. So that's why my 3 answers were all negative. Good stuff. So I just encourage you, I'm not giving you anything over half term beyond preparing for the mock. And I feel like we started quite early, which I hope is going to count in your favour, because actually if you follow the schedule there isn't a huge amount of work to do. I think I picked the 3 meatier topics for half term, but hopefully it's manageable alongside all the other stuff you've got demanding your time. So the week after half term I intend to just carry on with normal lessons, and then the following week, actually you haven't got maths until the week after that, but I'm aware that in that following week it'll be a bit in and out. So that following week is when we'll do a bit more of tree questions. So no new content, just some practice when you're here.
Can you give a
And-
revision, like, of the stuff that's
Well,
going
do you
on?
know what? I could do. The trouble is, it's just a bit too easy for me to do revision
Yeah.
lessons, and I'd much rather you were doing it independently. So sorry, the answer's no. But if you come along with questions, at break time and after school that want help, I'm very happy to do that. Right, take care, George. Have a good half term.